Today we're going to talk about integers and what they're used for, how we work with them, and then we will have time, just like always, to start working on the homework packet number 2 in class today. So integers, whole numbers, these are defined as whole numbers with signed values, either positive or negative. All right, so a couple of examples. It can be 50 degrees Fahrenheit or negative 50 degrees Fahrenheit outside. So things can be positive, things can be negative. Temperature is a good example of something that we actually have both dimensions of, and we use them both, although we use the positives more, right, where we live anyway. Another example is something like this. You can be 1,000 feet above sea level or negative 1,000 feet above sea level. Another way we talk about that one would be 1,000 feet below, right? So sea level 0, we go up, we go down. So positive numbers and negative numbers exist. Another common one, although I hope it's never happened to you, is your bank account. It can read positive $20 and it can also read negative $20. It's not where you want to find yourself, but it can happen, right? Those things can happen too. So to start with, we're going to look at number lines. So with number lines, the smaller numbers are always on the left, the bigger numbers on the right. We talked about number lines last time. But in particular, our negatives are going to be on the left if we go far enough, and positives on the right. So if we're taking a look at the numbers positive 10 and negative 7, what we would like to do is we would like to usually put 0 somewhere in between. So if we're looking at our number line, we have a 0 in between. And then if we're plotting 7, we'll mark 7, 10, we'll mark 10 to the right. So this one's 10, and we'll make a dot there. And if we're doing negative 7, we'll do 7 to the left. It's negative 7, and we make a dot there. The ones that you work on will typically be given to you already on a number line. There will be a number line there, and you're just going to find the location on the number line. If it's not clearly marked, you need to go out further, hash marks in each direction. Of course, you can do that. So when we're thinking about a number line, while 9 is less than 10, it's actually that negative 9 is greater than negative 10. So sometimes that can just take a minute to set in. We always think about numbers being bigger, or smaller based on where they are on the number line. So a number that is further left on the number line is smaller than a number is further to the right on the number line. So in terms of a number line, if we had been putting the negative 9 and the negative 10 on it, I'll put it back on the screen. Negative 9 would be here, and negative 10 would be here. So the negative 10 would actually be smaller than negative 9, even though 10 itself is larger than 9. The negative changes that direction. So we do want to be a little bit careful as we're taking a look that we don't get carried away and go too quickly, and just think about the 9 and the 10. So a couple of examples. We're just filling in the blank. You can use any of these 4 symbols to fill in the blank, which may mean, depending on the number, that there's more than one option that's acceptable. So on the first one, I have negative 3 and I have negative 10. So what symbol could go in the blank to make that work? So it's greater than negative 10. Yeah? Is there another symbol that would work?
Greater than or equal to.
Yeah, you could use greater than or equal to, right? So either of those symbols would be correct. Both of them would be counted correct because they're both true statements. given the 4 options that I have. How about the next one, 2 and negative 5? Yeah, greater than or greater than or equal to. So your pick. You can choose whichever one you want to use on those, and they'll both be correct. What if it had said like this? They are equal, but equal is not one of my 4 choices.
Either greater or less than.
Yeah.
And equal.
So you can use either the greater than or equal to, or you could use the less than or equal to, but you couldn't use the greater or the equal specifically, right? So there's different, structures for our numbers, and we just need to be very careful of what options we have with the directions given. Now, when we're adding and subtracting with integers, there's 2 different kinds of concepts we need to be careful of. The first is what we do when we have the same sign. So if the same signs are positive, we know what we do. We just add the numbers together. That's fine. 5 plus 5, right? 5 plus 7. But if one of them's positive and one of them's negative, it works a little bit different. So if the signs are the same, we add the values and we keep the sign. Okay. And like 5 plus 7 we'll use. So they're both positive. We add the values. It's 12. The sign's positive because 5 and 7's sign is positive. But we could do the same thing if we had 2 negatives that were being added, like negative 2 plus negative 4. They're both negative, right? So we add the signs. Signs are the same, and I'm adding them. So I add the 2 and the 4. Ignore the signs for the moment. What's 2 plus 4? 6. And since both signs are negative, I just keep the same sign, so it's a negative 6. Okay? If the signs are different, so different signs. Oh my goodness. If the signs are different, we will subtract the larger value minus the smaller value. And we will use the sign of the larger value. Good. Okay, so let me squeeze in an example here, and I'll just write the next one further down. So if we had the same numbers as before is fine. I can have 5 plus negative 7. So if I have 5 plus negative 7, the signs are different, right? One's positive, one's negative. So I'll take the larger value, and I mean by the value without the signs, ignore the signs, that would be 7. And I'll do 7 minus 5. What's 7 minus 5? 2. So this is what I'm sort of thinking, 2. And then the sign on the larger value is negative, so the sign on the 2 will be negative as well. It'll be negative 2. Okay, so you're keeping whichever sign is the sign from the larger one. It's a little more straightforward in our minds, I think, when we have the smaller sign being negative. So when you had something like 3 plus negative 2, well, 3 is already bigger than 2, so we automatically think 3 minus 2, and we just move on into 1 as though it's working with subtraction. So our mind sort of thinks that way naturally. It's the other case that's a little bit trickier to think about. All right, subtracting a negative. Last one on the screen. So subtracting a negative becomes a positive. So if we have 5 minus negative 3, right, a negative times a negative equals a positive. So when you see that double negative occurring, we automatically change them both to positive, and then we're simply adding 5 plus 3, and I have 8. So 2 negatives in a row will change to positives. I know you've seen all these things before. Any questions before we switch to the next page? Okay. So we're going to do some examples that involve these different features. And what I'd like to do is I'd like to just stop talking, let you do the 4 examples. Once you're done with the 4, I'd like you to turn to somebody near you, behind you, next to you, I don't care, and just make sure you've got the same answers. So just confirm that what you did and what they did matches. And if they didn't match, try and figure out who has an error in their reasoning. All right, what did you guys get on the first one? Negative 13. So these signs are the same. We add them together and we keep the sign of being negative. What did you get for number 2? 1. So these signs are different. So I would do 7 minus 6. That gives me 1. And the sign on the 7 is positive. How about 13 plus negative 15? Negative 2. So 15 is bigger. 15 minus 13 is 2. The sign of negatives on the larger 15. So we have negative 2. And how about 6 minus negative 2? Yeah, it's 8. Okay, so remember on this one we change both signs. 6 plus 2, and we get 8. Okay, everybody have those?
Yep.
Awesome. Okay, so let's talk about multiplication and division. With multiplication and division, we multiply just like you do with whole numbers, right? All your wonderful multiplication tables that you learned somewhere along the way, you will use them again. The only consideration that we have to do is to make amends for the fact that sometimes we have positives and sometimes we have negatives. So when we multiply 2 positives together, what do we get? A positive, right. What about when we multiply a positive and a negative? That one's negative. And when we multiply 2 negatives? A positive. And that's much like our subtraction of our negative that we saw on the couple slides ago. All right, so we've got a positive happening on the last one. All right, so same thing we're going to do on the next 6. You're going to take a look. Figure out what you believe the answers to be with multiplication and or division. I should make mention of, too, this fact about these multiplication facts, this works for division as well. So if I have a positive divided by a positive, it's a positive. If I have a positive divided by a negative or a negative divided by a positive, I've got a negative. And if I have 2 negatives divided, I've got another positive. So this works both with multiplication and with division. All right, so take a look at these next 6. You're multiplying them together. And then once you're done with those 6, compare notes with a neighbor. Make sure that you have the same things on all 6. Okay, did everybody get them? Got them all written in? You and your neighbor, you match? Huh? Okay, all right, let's see what we have. What do you have on number 1? Negative 18, very good. It's a negative because I have one positive and one negative. How about number 2? 32, and I have a positive this time, right? Because there's 2 negatives.
Go ahead.
Thank you. All right, number 3, negative 16 divided by 2. Negative 8. So again, I've got division, works the same as multiplication in the sense that the negatives, right? 1 negative, 1 positive. Good. How about negative 12 divided by negative 3? Positive 4. I've got a negative divided by negative. Okay, 5 and 6 we didn't talk about directly, but they're just extensions of what we did talk about, right? So I've got 3 numbers. What is 6 times 2 times 3? Yeah, 36, right? 36. Woo, goodness. And it's negative, right? Because there's 1 negative, 2 positives. Y'all have negative 36? We're working on multiplication tables in my house right now for sure. So my children can understand where you're at. It's all right. Okay, how about the last one? 2 times 3 times 4 times 5. 120. Is it positive or negative? It's positive. Okay, so how many negatives were here? There's 4 negatives here, right? Okay. So generally speaking, if you have an odd number of negatives, it's negative. And if you have an even number of negatives, it's positive. Another thing that you can do is you can take 2 at a time and say, hey, look, I've got 2 negatives, so I can cancel them both to positive. And I have 2 more negatives, and I can cancel them both to positive. So it's another perspective you can have when you're looking at whether these are going to be positives or negatives. Okay, any questions on those? Okay. Last thing in this section we're going to take a look at is distance. So the distance between 2 values is the larger value minus the smaller value. And I do mean truly the larger value. So this might end up meaning that the larger value is a positive. It might end up meaning that the larger value is a negative. But it doesn't matter what the value without the sign is. It's with the sign. Okay, so we're talking about the signed value, whichever one's bigger. So if we talk about the distance from 2 to 6, the distance from 2 to 6 is 6 minus 2 because 6 is the larger value between 2 and 6, right? And if you're thinking about it from a number line perspective, here is 0. We'll put 0 in. There's 2, and here's 6. And the distance is the space in between. So distance is always positive, okay? So anytime we do this kind of subtraction, we're talking about it being a positive value. If it helps you, you can think about it being an absolute value. That's fine too, it doesn't matter. But you're simply looking at the larger value minus the smaller value. And that can end up looking a little bit funny when we have things like this. Let's say we had the example that we were going from, hang on, we'll do negative 5 to 1. So I know that the number 5, if it didn't have the negative, would be bigger than 1. But when we look at negative 5 and 1, 1 really is the bigger value, right? So if you think about it from an algebra standpoint, this would be 1 minus negative 5. You'd change your signs, and you would get 6. If you think about it from a number line perspective, which is equally valid, here's negative 1, 0, 1, 2, 3, 4, and 5, like this. And the distance that's happening between these is 6. So if you were to count it starting here and you were to sort of make jumping counts, you'd have 6. Okay, so don't think that this means the same as just using the larger numerical value and ignoring the signs. The signs would matter on this. Any questions? Okay.